Okay, so let's continue here with the part 2 on our terms. So I'll tell you what we'll do. We'll start out first with categorizing our databases. Okay, generally speaking, we work with a couple of different types of databases, OLAP and OLTP. And you see this little Venn diagram here. The reason that I chose that is that many times you will find an OLTP database that also has a little bit of an OLAP functionality, a little bit of an OLAP twist to it. Maybe some of the tables are designed, I don't want to use the terms prematurely here, but let's just say that you can easily find databases with both qualities. Okay, so there you could say there's 3 categories. There's an OLAP database, an OLTP database, and some combination thereof. Now let's just break these terms down. Let's talk about OLTP. And this falls under that heading of industry terms. So this is online transaction processing. That's where our OLTP comes from, online transaction processing here. This is your normal database. Like earlier in the office today, we were looking up a CRM. We were investigating some of these, trying to find one here for Learn It First. So a CRM, in case you aren't familiar with that term, it's customer relationship management. Now that's just fancy word for I want to be able to track my sales. I want to be able to track my marketing. I want to know which customer came from which marketing effort, what the potential is that they convert into a sale. If they do convert into a sale, what that potentially going to be for us in terms of revenue. And now give me a report of the hottest prospects that we have. Like that's customer relationship management software. You could add ticketing systems into that. It can get really big or it can get pretty granular in terms of what CRMs do. But the point of using a CRM in this example is that there is a lot of write activity. So you see that right there, lots of write activity. So you're reading a lot of the data, you're reading the customers, you're reading like we have an e-commerce website, we're reading what the product list is, then we're displaying back to the person what is in their shopping cart. But when they check out, then we're going to write that activity into the database as well. So there's a lot of write activity. Now in an OLTP, you're going to have way more read than you will have a write, generally speaking. I can think of a few instances where it could kind of be the balance would be very different. But generally speaking, like in a CRM or an e-commerce website, you have a lot more reads than writes. Maybe 5 to 1, 10 to 1 reads to writes. I don't know. I'm just kind of guesstimating what that would be. Okay? So that's OLTP. Lots of database changes. Now, an OLAP database is primarily a reporting style, so online analytical. Okay? So this is, excuse me, generally speaking, this is going to be a mostly read database. The writes that do come in are going to often be done off hours during a batch load or a batch process. So what we'll often have in a case like this is we'll have our OLTP database be our main database that our customer relationship management software, for example, runs on. And that's what our users are in, and every day they're entering prospects, they're checking their pipeline, they're seeing what sales are going to come up and how much that's going to make them in commission so they can plan their vacations, right? So that's our CRM database. And then management is going to run these insanely complex reports that because of contention and performance problems, we can't run in the same database. So we're going to have an OLTP database, maybe our 500 gigabyte database on OLTP on one server, and then we'll have our 3 terabyte OLAP server over here for reporting because it's got the last 10 years worth of data line by line. It's got, I don't want to again use too many terms before we've had a chance to talk about them here, but it's going to be where we run our reports. But there's got to be a process whereby we copy the data out of the OLTP and we then put it into the analytical database, right? So that's a batch process. Every night, let's just give you an example. Every night at midnight, we run a SQL Server job that copies the new data in the past 24 hours from the OLTP and copies it into the OLAP. So we're not doing that in real time. We're doing that maybe once a day, maybe twice a day in a batch process, okay? A bulk load. And again, as I mentioned, sometimes you will have databases that, I don't quite have a 500 gigabyte OLTP or a 3 terabyte OLAP database. Maybe I have a 100 gigabyte database that kind of serves both functions. And eventually, yes, we know we're going to grow to where it's so big we'll have to separate them. But you know what? Right now, it's good enough. Okay, let's shift now to the third category, the data warehousing terms. So data warehouse, this is another one of those umbrella terms here almost. If business intelligence is extremely generic, data warehouse could actually be fairly generic as well. It means different things to different people. The idea of a data warehouse is you have a single location that everyone in the organization can go to and they can look up the facts. And by looking at the facts, we can make informed decisions quickly. We can even do forecasting against what has happened in the past and maybe will help us predict the future. So it's a single point within the organization that everybody can agree upon the facts. Now that may seem weird. Well, Scott, I don't understand. We've only got one OLTP database that stores our CRM. Of course, that's the facts of our organization. Why would we need a data warehouse? Well, the data warehouse in many organizations will collect data from lots of different sources. Like you may have your CRM database, for example, and that uses a SQL Server, let's say. But then you might have a customer ticketing system that uses MySQL and PHP for the website. And then you might have acquired another company who stored all of their customer information inside Oracle, and they have a mission critical application that all of the employees from that company still use and still dump their data into. Well, you want to have a single location to do all of your reporting from, and the data warehouse can now you can fill the data warehouse with data from all these different environments. Now, one important feature of loading that data is that you have to strive for consistency. You want your facts in the data warehouse to be unambiguous. You want to make sure, like I put this little bullet point down at the bottom, you want to make sure that everybody has the same information. So for example, in that Oracle database, the application developers that wrote it have a drop down. Somebody adds a new customer, and it puts USA into that Oracle database. Now, your CRM in SQL Server, it puts USA with 3 periods, U period, S period, A period. Now, when we load that into the data warehouse, we need to convert USA and USA to United States using SSIS, right, into United States so that we have a single fact that we can report from. We generally will see in the SQL Server world at least 2 different data warehouses here. And this again kind of falls to that idea of data warehousing being an umbrella term. You're going to have a relational database. Let me just underline this guy here. And that's going to be stored in your SQL Server, the database engine itself. It's probably going to be very, very massive, large amount of data, what we call denormalized data will be stored in that relational database. Now the second aspect, and this is really an optional aspect, you do sort of need to be at a certain level before this makes financial sense for you. You will then have a multidimensional aspect to your data warehouse as well. Now the multidimensional will store what we call the aggregations of the data that's in the relational data warehouse. And this is what we would use SQL Server analysis services for. So analysis services stores the pre-calculated aggregations. So now instead of you having to wait for SQL Server to crunch the numbers when you ask for, min, max, and average sales over the past 5 years by quarter, by zip code, or by salesperson, instead of you having to wait for SQL Server to aggregate all those rows, Analysis Services has it already calculated. It's just sitting there waiting for you to ask it, and it hands it back to you. Now, I just wanted to diagram here a quick ETL process for you. So here's what we'll do. We'll just I think about it like this. We've got our Oracle database here, and then we've got our SQL Server CRM over here. And these are our OLTP databases. Okay. Now, a batch process, a nightly process, somehow will load, extract, transform, and load, okay, into, oops, I'll go ahead and write one of these here. This will become, let's just see if I can, right there, relational data warehouse. And so that is a SQL server. Okay. So then, and you might have staging tables and other things that some of you may be more familiar with those terms. Oops, sorry about that. And so then from here, we then will load our cube. And so we will have an analysis service. Let me actually make that blue. Like an analysis services cube. You remember how I said earlier that we had a multi-dimensional database? Well, that's kind of what I'm talking about here. Draw these out. Okay. And so this is SSIS. And this is actually a very, very typical data warehousing environment in the Microsoft space. If you're using SQL Server, this is probably what your system is. You may not have Oracle over there. You may have any number of things. I mean, we can have Excel access. I mean, it just depends on the organization that you're working with, what's on the left side of this screen. But generally speaking, the component in the middle and the one on the right, that's going to be what it is. Now, just to make sure you understand, if you see different terms or if I say different terms later on in the course, you know what I'm talking about. There are several names that you'll see OLAP databases go for. Data warehouses are called DSSs, ESSs, OLAP servers, reporting databases. They go by lots of different names, so look out for those. If somebody says, well, we've got our analytics database, they're probably talking some form of a data warehouse, whether it be a relational data warehouse, a multi-dimensional data warehouse. Just be prepared. Now, a data mart is a subcomponent of a data warehouse, generally speaking. It's a smaller grouping within it. So we might have a sales data warehouse. And then for data marts underneath the sales, we might have an internet sales data mart. We might have a brick and mortar sales. So there's smaller groups within a data warehouse. Generally speaking, you're going to spend a large portion of your time as an SSIS developer dealing with data quality issues. So this is a real big term to know, data quality. Remember garbage in and garbage out? I love my friend Ephraim. I was a training one time, and he used this just a brilliant example of data quality. And he said, here's how he thinks of data quality. You've got this clear pool, beautiful blue water, nice sunny day, you're out relaxing, and somebody walks up with a cup of red ink and they throw that cup right in the middle of your pool. Are you going to be able to get that out with a net, with a sieve? No, it's just going to go right through it. You don't want that to happen to your data. Garbage in, garbage out. You want to prevent it from getting in the first place, right? or you want to put in data control measures or data quality measures that help the consistency of our database. Okay? You want to keep that, or you want to preserve that nice clear blue pool. Okay? So data scrubbing, here's a bunch of terms here. I just kind of lumped them together. Data scrubbing, data cleansing, data validation, data translation. Data translation is where we're given one term. We have to maybe do a lookup in another area to figure out what the new value of that term would be. So if you've ever done a lookup transformation or lookup queries, you're probably very familiar with data translation. Just kind of converting one value in one system to another value from another system here. Deduplication, deduping, a dedupe, all terms you'll see. This is simply removing duplicates. I don't think I've ever done a legacy import of a contacts type table that didn't have duplicate contacts in it. It's just inevitable. Depending on how the system was written, I've seen them do everything from just changing the case of the name would cause a duplicate. It wouldn't be interpreted by the application directly. To different addresses, but yet the same person. So instead of having a one-to-many relationship between person and address, you have a one-to-one relationship between person and address. And if you want somebody to have the same to have two different addresses, you had to enter two different contacts. I know that sounds silly to you, and nobody would design databases like that, would they? Yeah, they do. Yeah, they sure do. So you're going to spend a lot of time on that data quality. I had a nice link. I don't know when you're going to be watching this, but I thought this was a brilliant page. I'm recording this in 2009, and this is a great glossary of terms. So you can go to get a little bit more information. Whether it will be up in 2012, I can't tell you, but you could try. All right, in the next video, what we're gonna shift gears. If you stay with me here in chapter 1, we're going to talk about what's new in SQL Server 2008's SSIS. Or if you don't, you can go on to chapter 2 or go on to the next section. And FYI, if you like these little Wordles, as they're called, you can actually make them. I made these over at Wordle.net. It's so easy. It's such a great little visual component there.